Hi, and welcome to the final video in this series on simultaneous equations. Simultaneous equations 5, putting it all together. I'm only going to show you one example in this case, and as you can see the example's there, and again I urge you, pause the video, have a go at the example, and come back to me. What I am going to do in this video is I'm going to show you how you could solve this example using both elimination, substitution, verify, and then I'm going to show you what it looks like graphically. And as I do that, I'm going to talk to you about why and how you would choose whether to use elimination or substitution. It's very important now that you understand how to do both. In some cases, one will be a lot easier than the other. So in this case, I'm going to start by using elimination. And if I was doing this question, equation 1 and 2, I'll get equation 1, multiply that by 3. That will give me the same number of x's. 3x plus 6y will equal 3. I'll call this equation 3, and now that I've done that, I can see that it's going to be really easy to subtract equation 2 from equation 3. 3x plus 6y equals 3, and I'm going to subtract from that 3x minus 5y equals 36. They cancel out. 6y minus negative 5y is 11y, and 3 minus 36 is negative 33. Divide by 11, and it gives me y equals negative 3. Then I'm going to substitute this back in, and that will give me x plus 2 negative 3's equals 1, which gives me x minus 6 equals 1. I'm going to add 6 to both sides, and it'll give me x equals 7, and then I'm going to verify as required. Same question again, this time I'm going to use substitution. I'll call them equation 1 and equation 2, and I'm going to look at equation 1 where x clearly equals 1 minus 2y, and I'll call this equation 3. Then I'm going to substitute that into equation 2, which will give me 3 minus 5y equals 36, and inside there instead of x I've got 1 minus 2y. And now I'm going to expand my brackets to give me 3 minus 6y minus 5y equals 36, which gives me 3 minus 11y equals 36, which gives me negative 11y equals 33 if I subtract 3 from both sides, and that gives me y equals negative 3 if I divide by negative 11 on both sides. Now I'll put y equals negative 3 back into equation 3. Negative 3 into equation 3, which gives me x equals 1 minus 2 times negative 3, which is 1 minus negative 6, which equals 7. So x equals 7, y equals negative 3, and I'm going to verify this result as required. You'll see here that I've gone back to my website desmos.com, and I have drawn the two graphs on a set of axes. I've labelled those two graphs, x plus 2y equals 1 and 3x minus 5y equals 36, and you can clearly see where they're connected. But you'll see here that I've circled in the middle the point where they meet, and that point is there, which is x equals 7, and there, which is y equals negative 3. So x equals 7 and y equals negative 3. And you could go through the process of verifying that again, but you'll notice if I go back up to my previous methods, this being substitution, I got x equals 7 and y equals negative 3, or this being elimination, and I got x equals 7 and y equals negative 3. So in all my previous methods, I got the same answer. Of course, you can verify here. Graphical method is about drawing the two graphs and finding where they intersect. Elimination method is about subtracting or adding your two equations in such a way that a variable is eliminated. And substitution is about making one of your variables the dependent variable in the relationship and then substituting that variable out for what it's equal to, and then solving the equation. Sometimes one method will be easier than another. You have to continue to practice to get to the stage where you're confident picking which one is the best method to use when. All the best and good luck with simultaneous equations.